Well, like it stops once you get to a number.
Right. As long as you don't have any leftovers.
We did both ways, in the calculator and you see that? You understand where I'm getting from?
Yeah, that's annoying.
Okay.
I do really like the coffee.
I just wrote it by design two.
I really like the coffee.
So I know that's why I got the 2 and 166, right? And then I got 162 by 2. Because I knew it could be the end of the 2.
Here's a pair of threes.
200 plus plus.
Here's a pair of twos.
81.
Here's a pair of threes. You understand these sixes broken down first.
That's about what I did.
Now your answer is three.
3, 3, 9, 3, 3.
So you take one out of each pair.
Since
Yes.
we're
Three,
square
six,
root of
six,
2
calculator.
to the power 2 is opposite, right? I mean, we can circle those 2 is right with those.
Which, by the way, if you take the square root of 324,
We got rid of all those. Yep. Since we circled it, now we out of the thing.
correct answer for this one is 18. You can either break it down all the way and then multiply all the parts together, or you could just stop at 18 times 18 and say that's a pair and be done.
And that,
All right, hands up if you want to come show us how you did it. Prizes.
This is with 18 also.
1, 2, 3, 4.
For 2. For 2.
1.
You guys can stop it.
Deep breath.
I'll be here for cross this off for you.
Yes, you can. You want to use marker?
It's fancy.
Okay. So this problem was kind of already half done. So you multiply square root of 6, square root of 54, and then it gives you square root of 324. And then 324 is a perfect square, and it is 18 times 18. And since you can't really divide that down anymore, you just circle that as a pair.
You
Wait,
can't divide it down.
6 and 3? I thought it's perfect square.
You can do
No, it is. I mean, this is right.
yeah.
No, I'm talking about like, okay, anyway.
No,
so
it's not
anyways,
prime.
6 and 3.
She want me to do.
You could keep
Yes.
going if you want
So
to.
you can
I did
split
it
two
the-
18s into 6 and 3, and then 6 and 3, and then you can split the 6s into 2 and 3. And then you
I got
multiply them, and that'll equal 18. So.
Yep.
It's just.
So you get like a pair of 2s, a pair of 3s, and a pair of 3s. And 2 times 3 times 3 is 18. Or you could have stopped when you saw that it was a pair of 18s. And said, there's a pair, I'll take it out. Great. Go get prizes. Sorry. So the answer is 18. Aww, you guys. So cute. All right, let's try.
Like I could have stopped at 9.
This one. Cubed root of m times the cubed root of m squared. All right, now they're both cubed roots. What do we do with the insides? We just multiply them. What's m times m cubed? M cubed. Nice. If you break down the m, that's just 3 m's, like the company. Which is just m. Another fun way to look at this, I don't know if I'd call it fun, I guess, but this is m to the third on the inside, right? And then what is a third root? What power is that? A 1/3 power. Do you see how like they would cancel, those powers cancel each other out? And you're left with just m. Either way it works. Okay. Next one. We'll talk about rationalizing denominators another time. I don't want to do that right now. Okay. Square root of 7/64. What do you do if there's a square root over the whole thing? Yeah.
We can split it up and let's do a square up at the top and square up at the bottom.
Right. Square root of 7 over the square root of 64. Square root of 7, can I break that down?
No.
And the square root of 64 is 8. That's how complicated that one is. What else did I want to talk to you about? 8b. Okay. Why don't you try this one and I'll give a prize for this one. What am I on, 7?
Yeah.
The 6th root of x to the 12th, y to the 3rd. All right, talk to your partner, please. Talk, guys, talk.
Since it's x squared, we can, so 6, so then it'll be x2 times y is 2/3 and 2.
I think we just.
6 power over
Yes, we could.
and then 5 times it. I think you might like square.
Why?
Yeah, I think we can minimize it more. I think not. I'm not sure that's everyone.
Oh, wait, yeah,
I'm pretty sure we can minimize it
I think
to
it's x to the.
y and square root x.
X to the.
So it's x squared times y and square root.
Oh.
Yeah. So that 2 is assumed.
Yeah. We're like, I'd say 5 minutes away. All right. Guys ready? Correct answer is x squared on the outside and, right? Yeah, and then the inside is y to the 3rd, or you could call it the square root of y. You want me to talk about that?
Why don't we have the
You mean like the whole?
So it can just be x squared square root of y?
Yep.
Yep.
So it could be
Why
simplified.
is
Yes.
It's still right.
What?
Why is there a little 6 on the outside?
Okay, let me talk about that. All right, I'm gonna try this one, guys. Be polite. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2 groups of 6, right? And you got 3 y's, and they're not a group of 6. So 2 of these come out, that's just x squared. Everybody okay with that so far? Okay. And then you've got like a 6th root, y to the 3rd.
Wait.
A 6th root with a y to the 3rd on the inside.
Yeah, you didn't say the 6 part.
Right, and because you can actually simplify this to this. X squared, remember that that's like a 1/6 power, right? So if I rewrite it as y to the 3rd to the 1/6, do you see if I multiply these fractions together, I would get 1/2 or 3/6, which is actually x squared, the square root of y. Now, I'm not going to be that picky. This is the better answer, but I would take this one on a test. Because they're both right, and that's a little tricky to understand. Yeah?
How did you get the x squared again?
Because I had 2 groups of 6 x's. Or I guess you could think 12 divided by 6 is 2. Okay. Last one we're doing today. Very last. We're going to talk about rationalizing a denominator. Did you guys do this with Mrs. Sickink?
Maybe.
Okay, let's try 4 over the square root of 3. Now, this is a stupid math rule. I hate stupid math rules that have absolutely no reason to them. I guess the reason why this math rule exists is so that mathematicians, like, you know how like your answers can all look very different. Like, remember when Ryan was saying